Alright, it is section 6.1 time. Our last two sections coming here. As you can see, the title, Solving Trigonometric Equations. And we've done some of this already. We end up using inverse trig functions to find angles and things. Just a few little added features here for what we're doing in this section. And in fact, the first thing we need to do is, as it says, look back at coterminal angles, which we started talking about a long time ago. Alright, find the angle between 0 and 360, or, and this is new at least, between 0 and 2 pi. That's coterminal with the one that's listed there. Now, what we saw before is that to get angles that are coterminal, you take the angle you have and you just add or subtract 360. Alright, you're spinning all the way around once, and you end up pointing in the same direction, but with a different angle measure. So, depending on whether you're above or below our standard range, we add or subtract 360s, or if it's in radians, you add or subtract 2 pi. So, I have the notes filled in here, so I'm just going to show you. So this first guy is 800 degrees, and so you subtract a couple 360s and you get 80. So 80 and 800 are coterminal with each other. Negative, you'd have to add some 360s, and to do that a couple times to negative 660, and you'd get 60 degrees. This guy's in radians, so if you think about what we've got here, 22 pi over 3. So the denominator is 3, and if we want to add or subtract 2 pi, well, we need that to have a denominator of 3. And 2 pi, if we think of that as 2 pi over 1, multiply the top and the bottom by 3, so we would have 6 pi on top and 3 on the bottom. And that's equivalent to 2 pi, but with the same denominator. And it turns out we got to subtract, well, we want to get in between 0 and 2 pi. Now, like if you subtract one of those, you'd have 16 pi over 3, and if you just think about the fraction of pi, 16 over 3 is still more than 5. You subtract another one, you're down to 10 over 3, but that's still more than 3. So if you subtract another one, you're down to 4 pi over 3. And 4/3 is smaller than 2, so that's within our range from 0 to 2 pi. And the last guy is negative. And to add 2 pi, in this case, since it's negative, we need 2 pi written with a denominator of 5, which means multiplying top and bottom by 5. And if we add one of those, it would still be negative, so we add another one, we get 9 pi over 5. And 9 over 5 is less than 2, so this is less than 2 pi. Alright, so we got to remember that. How do we get to coterminal angles, add, subtract 360s, or 2 pi's? Okay. So, turning this around, and we've done this before too, well, what if we have a particular angle, we want all the angles that are coterminal with it? Well, it just means you add any number of 360s or subtract any number of 360s to that thing, and you get a list that looks like this. Alright, there's the 100 in the middle, coterminal with itself, add 360, add 360, subtract 360, subtract 360, and so on. It's a little clunky to write out this list, though. You got to put your dot dot dots at either end. You got to have a decent number of examples, and so a shorter way to express this big list is just to basically describe how we got the list. We started with 100 degrees, and then we added or subtracted any number of 360s. And one way to denote adding or subtracting any number of something is to take any integer times that thing and add it on. So like you could, to add 5 360s, you could just multiply 360 by 5 and add it to 100. To subtract 19 360s, multiply 360 by negative 19 and add that to 100. And so in a short notation, we get something that looks like this. So, oh, and I am missing, and so this will be missing in the notes I scanned too. Oh, well, okay, no, I did say it right here. There's nothing special about the letter K, it's just the one that we're choosing to use. K represents any integer, right? 100 degrees plus any integer multiple of 360 gives you an angle that's coterminal with 100. Right? So, to do that, and similarly in radians, well, instead of 360s, it's 2 pi's. So all the angles that are coterminal with 7 pi over 6, you could make kind of an awkward list and have to come up with some examples, or you can just say 7 pi over 6, add any multiple of 2 pi, any integer multiple of 2 pi, and every single one on the list looks like one of these guys. Alright, so this is just a nice shorthand mathematical expression for this whole infinite list of angles. Alright, so when we get down to solving equations then, I'm going to start doing these live a little bit more. Sometimes we need to take the equation we have and rearrange some things in order to get something that we can use an inverse trig function on. But then we're going to keep in mind when we are asked, sometimes if you look in the past when we solved some equations, it said find the solutions to this equation for theta between 0 and 360 degrees, something like that. Well, now we will have the language where it says find all the solutions. And that means including every angle that's coterminal with the basic solutions that we found. Alright? So, some of this should look a little familiar, at least, when we do it, but there will be a little added twist in here, too. So, we have 2 cosine x plus 4 equals 5. Alright, so this is example 4. Alright, so, well, whenever we're solving an equation, we're basically trying to get the variable by itself. And when our variable is inside a trig function, it means getting the trig function by itself first. So, subtract 4 from both sides. Divide both sides by 2. And we're down to this. Alright, so, if you remember how we did these before, what we ended up talking about is, well, where is cosine positive? So first off, quadrant 1, quadrant 4, yeah. So where is cosine equal to 1/2? Alright, well, you can remember from a unit circle, you could get out your calculator. Our strategy before was find the reference angle for solutions, and then use that reference angle to find the angles in those quadrants. Now, whether you look it up on your unit circle, inverse cosine of 1/2 is 60 degrees, and that would be our quadrant 1 answer right there. For quadrant 4, we would do 360 minus 60, so that's our quadrant 1 answer, and it's our reference angle. And our other answer would be 300 degrees. Alright, now in the past, we stopped right there. We found 2 solutions, and that was it, because we were only looking for answers between 0 and 360. But now, what we're going to do is to list all the solutions, all the angles you could possibly put in for x. It would include anything that's coterminal with 60 or coterminal with 300. Which doesn't require us to do a whole lot of work, it just requires this step for writing up the solution. X equals 60 degrees, and anything coterminal with that. And the easiest way to express that is to say plus 360 times k. But then also 300 degrees, and anything coterminal with that, which would be 360 times k. And since you introduce this letter k sort of out of nowhere, you have to say what that thing represents. And like we said before, k is any integer. So any integer you pick, put it in for k, you get a solution to this equation. So there's an infinite number of solutions. 60 and 300 are kind of like the basic ones in our basic range from 0 to 360. But then we get all these other guys that are coterminal with it. Now the example does say find the solutions in radians as well. Now having found them in degrees, you can just convert them. If we do it in radians, 60 is pi over 3, 300 is 5 pi over 3, but now we have to represent anything coterminal with those guys, and so we say the same thing, but instead of 360 it's 2 pi. k any integer, like so. Alright, so next problem, same sort of situation. We need to rearrange some things here first. Real quick, jot it down. Sine theta minus 7. Alright, get all the sine thetas by themselves. So I am going to subtract 2 sine theta from both sides. So 4 minus 2 leaves us with 2 sine theta. I am going to add 6 to both sides. So adding that to negative 7, we still have a minus 1. So divide by 2, we have sine theta equals negative 1/2. Alright, negative sine function, that would be quadrants 3 and 4. Now, inverse sine of positive 1/2, remember to get the reference angle, we ignore the minus sign. Alright, this would give you an answer, but it isn't even necessarily in the range from 0 to 360. Or if you put the minus sign in, you wouldn't necessarily get an answer between 0 and 360. Inverse sine of 1/2 is 30 degrees. So quadrant 3, we would take 180 and add 30, so 210. Quadrant 4, we do 360 minus the reference angle, so 330. But then, like the previous problem, those are our basic answers. Those are the 2 solutions in our standard range from 0 to 360. So now, x equals 210 plus 360k, 330 plus 360k, k any integer. Or, put it in radians, that is 7 pi over 6 plus 2 pi k, that's 6, and 11 pi over 6 plus 2 pi k, k any integer. There we go. Alright. I'm going to close my email so it stops dinging at me a sec. Okay. And that's the end of that one. Okay. Next page. That was example 1, 2, 3, 4. So at least in my notes, the next page says example 5 for both of them, but there's just more examples on the next page. Alright, so let's just call this page 2. Alright, more things to deal with here. Alright, so top of the next page, sine squared theta minus 5 sine theta plus 4 equals 0. So how's that for something different from what we've seen before? Alright, and if you notice the instructions, it says find all the radian solutions, so that's what we're going for. Okay, well, the way we're going to think about this, now we have sine squared, we have a regular sine, we have something that doesn't have signs in it at all, so what do we do with that? I'm going to introduce another letter just to simplify some things. So I'm going to let t be sine theta. And if t is our sine theta, then this equation we're solving, I'm just going to replace the sine thetas with t, would be t squared minus 5t plus 4 equals 0, which hopefully looks more like something you've dealt with before. That's a quadratic equation, and the way we solve that would be by factoring. Alright, now without going a long review of factoring, we put a t, we put a t. Since this is positive, these two numbers need to have the same sign, and since that's a negative, they both have to be negative. And then numbers whose product is 4. You could have 1 and 4, 2 and 2, but to get negative 5t, when you FOIL out your factors, it has to be 1 and 4. So, set each one equal to 0, t minus 4 equals 0, we get t equals 1, t equals 4. But then when we remember where this came from, alright, t was sine theta. We just used him to stand in for sine theta so we could do some algebraic work in a way that looks familiar. So going back to where this came from, we're now trying to solve two little separate equations. Sine theta equals 1, sine theta equals 4. All right. Well, unit circle, inverse sine, whatever you do, there's only one angle whose sine is 1, and that's 90 degrees. But here we're doing radians, so pi over 2, in other words. Sine theta equals 4. If you try to do inverse sine of 4 on your calculator, you are going to get complained at. And it'll say domain error or something like that, because there is no angle whose sine is 4. Right? We know that when you take the sine of an angle, it comes out between -1 and 1. So here, you can see at this point where we break the factors up, it's kind of like a little fork in the solution road. And one of our roads hits a dead end. Alright, that doesn't mean there's no solution for the whole thing, it just means that down this path, no solution. Here we had one, just one. And so to finish off the problem, since it's asking for all the radian solutions, well, pi over 2 plus anything that's coterminal with it. So add our 2 pi k, any integer. Okay. All right, off over to the right on page 2. 2 sine x cosine x minus cosine x equals 0. So factoring and trig equations is not something we've run into before, but that is what we're running into here. So we have two different trig functions involved, which isn't helpful by any means. But there is just two terms, and we already have a 0 on this side, which is helpful when we're solving. And one way to look at this is, well, if you're factoring, the first thing you look for is a greatest common factor. You look at all your terms and see if there's anything that all the terms have in common, and these two terms definitely both have cosine x. So I'm going to factor out cosine x, and then write down what's left over from each term. So we took out cosine x, leaving us with 2 sine x from that one, minus, well, and when you take cosine x out of cosine x, the term doesn't go away. The result is what happens when you divide by cosine x. Well, we just have a 1. So now we have factors equal to 0, just like we did over here. And the way we deal with that is you set each factor equal to 0. So we have cosine x equals 0, and we have 2 sine x minus 1 equals 0. So if we solve this guy, we add 1 and divide by 2. This one turns into 1/2 pretty quickly. So then off the unit circle or whatever, since 1/2 is one of our standard trig values. In radians, let's see, that happens at 30 degrees and 150. So pi over 6 and 5 pi over 6. Cosine equal to 0. So where on the unit circle is the x-coordinate 0? Well, that's at the top and the bottom of the circle. That's 90 degrees, pi over 2, 270, 3 pi over 2. So we end up getting inside this range from 0 to 360, or 0 to 2 pi, since we're doing radians, 4 separate solutions. So to write all the solutions for this equation, it's these 4 guys plus anything that's coterminal with them, which makes it a little long to write the solution, but here we go. Pi over 2 plus 2 pi k. 3 pi over 2 plus 2 pi k. Pi over 6 plus 2 pi k. 5 pi over 6 plus 2 pi k, where like before, k is any integer. Whew, like so. All right. Couple more examples, and then the rest of the section is stuff for you to try. So, continuing, this is page 2 continued for 6.1. We have a very different looking equation. Sine a minus 22 degrees equals 0.83. Okay, find all the degree solutions, which means finding the degree solutions in the basic interval and then adding anything that's coterminal with those guys. Now what's a little different about this guy is that what's inside is not just x or theta, it's a minus 22 degrees, right? Now if you want to, you could just think, well, let's call this thing theta. So what we're really dealing with is sine theta equals 0.83. So it's a sine function, we're talking about a positive value, so quadrant 1, quadrant 2, inverse sine of 0.83. We're working in degrees here, so make sure you're in degree mode. 56.1 degrees is what I've got. And that's in quadrant 1, and that's our reference angle. So there's our quadrant 1 angle. Quadrant 2 is 180 minus the reference angle. So that would be 123.9 degrees. So if we were solving sine theta equals 0.83, we'd be done. We'd have this guy, we'd have this guy. We would just add 360k to both of those to get all the coterminal solutions too. Alright, but we're not solving for theta, we're solving for the variable a. And so what we get down to now is that theta is 56.1, or 123.9. So a minus 22 is 56.1, 123.9. And so to get a, well, add 22 to both sides, which means adding 22 to both solutions. So a is 78.1 when you add 22 to this, and 145.9 when you add 22 to that guy. And then to really finish it off, it's these two basic solutions between 0 and 360, and anything coterminal with them. So we get a equals 78.1 plus 360k, 145.9 plus 360k, k, any integer. There we go. Alright, one more on this page. Minus 5 cosine t plus 2 equals 6. Alright, so this one, well, it's just cosine t, at least. Nothing's squared, there's just the one trig function, and that's all. We just need to get the trig function by itself. So, subtract 2 from both sides. Divide both sides by minus 5. And there we are. Now, cosine and a negative value. That is quadrant 2, quadrant 3. And I'm going to do inverse cosine of positive 4/5 to get the reference angle for that. So, if you do that, 36.9 is what would come out of your calculator in degree mode. So in our two quadrants, quadrant 2 is 180 minus that guy. Quadrant 3 is 180 plus that guy. So we get 143.1 degrees and 216.9 degrees. And to make sure we have all the solutions, it's these two plus anything coterminal with it. So in the end, our variable t is 143.1 plus 360k, 216.9 plus 360k, k, any integer. The end. All right. I would suggest that you go try the group exercises now. There's 2 pages. There's 4 problems total. Many of them are similar to things we just did. Rather than writing out everything that is done, I'm just going to take the filled out notes and I will put them on the screen here and just make comments on it and just finish up the video that way, but it would make all sorts of sense for you to pause the video and go try those guys and see how they turn out. Alright. But at this point I'm going to move on and we're just going to look at these and we'll see how they turned out. So, number 1, degree solutions for this guy. Isolate sine theta. Subtract 3 square root of 3 from both sides, divide by 6, and what you end up with is another familiar value for a familiar trig value. And sine theta gives you that value. Well, first off, it's negative, so it's in quadrants 3 and 4. And you could just look them up on the unit circle and jump to the answer. Or, if you do inverse sine of positive square root of 3 over 2, you get a reference angle of 60. So in those two quadrants, ding ding, there's your two answers, 240 and 300. This little picture just kind of shows where they are. Negative square root of 3 over 2, that's that decimal we know is 0.866 with a negative sign. And sine is the y-coordinate, so on the unit circle it would be like, where's the y-coordinate? Right around here, and you get one right there, and you get one right there. And then to wrap it up, well, since we're looking for all the degree solutions, add 360k to both of those guys and you're done. Alright, number 2 had a little twist to it. So first off, we've got to get the cosine by itself. Now it's squared, but it's the only trig term there is. There's not another cosine term like we had in that previous example. So you can actually just get this guy by itself and take a square root. So add 2 to both sides, divide both sides by 4, and, well, 2 over 4, it's 1/2, but we're going to take a square root. So you take the square root of both sides, and you get square root of 2 on top, and you get 2 on the bottom. But when you take a square root, when you're solving like this, you got to remember, since we're talking about a square being equal to a positive number, the square root could be the positive or the negative version of it. So we are talking about cosine x being plus or minus square root of 2 over 2 in this case. Which means we're talking about cosine being positive or negative, which means we're talking about all the quadrants. So now then you can think of it as, well, the reference angle in the first quadrant is 45 degrees, or pi over 4. And if you just whip around the other 4 quadrants in radians, since we're talking radians here, it's these 4 guys. And this is the 45, 135, 225, 315, those guys. But since we're talking about all the solutions, add 2 pi k to all 4 of them, k any integer, and there's your answers. Okay. Last page for 6.1. Let's get sine t all by itself. Okay. Subtract 4, gets us a 5 there, divide by 11. Sine is a positive number, quadrants 1 and 2. So now that's not a familiar trig value, so we get out inverse sine and do that, and going to the nearest degree, 27 degrees. Now that's our quadrant 1 answer, but also our reference angle. So in quadrant 2, we got to do 180 minus, we get 153 degrees. We tack 360k onto both of those to get all the angles coterminal with those guys. K is any integer. Alright, number 4, the tangent function. So first off, well, we got tangents on both sides, so let's gather our tangents on both sides. So subtract 7 tangent x from both sides. 9 minus 7 is 2 of those. 17, we'll subtract 2 from both sides, so we got a 15. Divide by 2, and we are talking about tangent being, well, 7.5, 15 over 2. We are doing radian answers here, too. Let's keep that in mind. So, tangent is positive. Quadrant 1 and quadrant 3. So we'll do an inverse tangent, and that will give us our reference angle. Now, a little different from most of the examples we deal with, this is in radians. So I put my calculator in radian mode and did inverse tangent of 15 over 2 and got this reference angle in radians. Now, that's also our quadrant 1 solution. Okay. But then we got to get the quadrant 3 solution. And in quadrant 3, you take 180 degrees, which in radians is pi, and add your reference angle. And so pi plus 1.44 comes out to a nice 4.58. And then to make sure we have all the radian solutions, we got to add a 2 pi k to both of those to get all the coterminal solutions as well. Alright, now you could do this problem, this part the same, then do everything in degree mode, find the reference angle, find this solution in degrees, and convert everybody to radians at the very end if you wanted to. But it's okay to handle it just in radians as well. Okay, that's 6.1. And that's the end of the video.